ladies and gentlemen, to meet or not to meet, here is Manuel Kälin.
Thanks. Presentation. Okay, very warm welcome from my side. My name is Manuel and I'm a biotechnologist. I'm absolutely happy to be here today and to introduce Luma mold-aged products. Luma mold is not just, many thanks. In the first part of the presentation, it will be a little bit a scientific presentation indeed, but it's also really a scientific topic. In the first part, we're going to look a little bit about what Luma is and how everything began. In the second part, we're going then we have to understand how the mold is acting on the meat and how he is acting or connecting with the connecting tissue and with the muscle systems. And at the end, we're going to see what the maturing process is doing and some impressions out of our productions. Well, what is Luma? Luma is high-quality meat. It's not just mold-matured meat, it's beef, pork, and veal, which we're maturing in our rooms. And it's also kind of a Swiss innovation. Lucas and Marco had the idea of improving Swiss meat because Swiss meat is always a little bit changing in quality. It's not that stable like in the USA or in Australia. So they tried to find a way how they could improve the Swiss meat quality. And indeed there is a way, because the fusion between, if you're looking at the dry aging method, which is really a well-known process, combined with modern biotechnology, we're able to produce a product which has a new level and a new standard and brings the meat on the next level. So the fusion of tradition and biotechnology is a really important point here to make this product. Everything began in 2010 with this, let's call it a little bit a beer drinking idea. Because it was really like just, hey, come on, is it possible to do the meat better? Yes, it is. So let's think about biotechnology, let's think about a mold. And since then, so many things has changed. It's not just a paper research in the beginning and found a good mold which is doing the things we're looking for, aroma changes, and also changing in the texture. No, it's just today we are award winners, we are patent holders, and we are about 25 employees in the Swiss and national market. Our business was scaled from the Swiss to the EU market, and also as well with Nice to Meet, we heard before, as a partner in the Benelux states, we're able to produce Luma mold-aged products and bring it here to the Benelux. Well, so many chefs already worked with Luma products, and perhaps some of you already did. So Heston was one of the first. He visited our production in 2014-15, checked our lab, checked our production, and he was kind of excited to have a new possibility, new taste to bring back in the kitchens and to creating cool dishes. Also, Andre Jäger was one of the first clients. So he was a former 19 Gomio chef, and he's well known, especially in Switzerland, but perhaps some of you already know him. But it will be a little bit a scientific presentation, but it's really important to understand how the mold is working here, and for that we have to understand how the skeletal muscles are working. So meat is nothing else than just skeletal muscle. By the way, it's the same like we have, so it's not quite a big difference between the muscles from an animal or the muscles from a human. The composition is always like about 75% of water, some proteins, and of course fat. So the fat ratio is always a little bit different. If we saw the presentation before with the Japanese Wagyu, we have a lot of more fat in it, of course. But if we compare it with an Irish grass-fed product, so it's a little bit leaner. But what all of these products have the same is the connecting tissue. So the connecting tissue is all around in this muscle system, and it needs to have a lot of this connecting tissue, the collagen, because that's the only way that the muscle is holding together and the whole muscle structure fits like on doing his work as he should do. If you're looking a little bit closer to this picture here, we're able to see here really on the top a whole muscle system which consists out of a lot of muscle fiber bundles. The whole bundles are always wrapped with this gray layer we can see here. So this layer is just the connecting tissue, the collagen. If we're zooming a little bit more in, just looking at one muscle fiber, so we can see that there is also the muscle fiber is surrounded by this connecting tissue and holds everything a little bit together. So that's the reason why some animals are having more collagen in the muscles, or some muscle groups are different, because an animal is using their muscle always a little bit in another way. As you can think out about a cut from the back, it's really tender because there are not that much collagen and the muscle structure is different. But if you're looking at the neck piece, so of course the animal is doing and using the neck a lot. So you have to cook a little bit different because it's more connection tissue in it and the muscle fibers are a little bit set up in different ways. To understand how that is working, we have to discuss the sarcomeres. The sarcomeres are the smallest functional unit in the system. The sarcomere here, as the smallest functional unit, is always, maybe you heard it from school back in days, myosin and actin filaments. So we have the myosin filaments here in red and the actin filaments in blue. These are always covered at the side by these set discs. And these set discs are exactly the point where we're acting during maturing with our mold. That means our enzymes from the mold are getting into the meat and is doing there his work. The main question here is a little bit, why is he doing that? Why is the mold acting like he's doing? We see it on the next picture in a really good way. So we're looking here on the back ribs of a ribeye. It looks crazy indeed, but it's also fantastic because the first question was really, why is he doing that? It's just about, it's a win-win situation. Our mold is loving the meat as a food source, and for us, it's the cool thing, he's changing the aroma profile and also the texture of the meat. And for that, he's bringing his natural enzymes into the meat. The most interesting part is not what we're looking here. So it's good looking, but in the black box, under the surface, there is really happening the cool thing. So we see the surface mycelium, it is just what we saw before. It's good looking, but for me as a biotechnologist, not really interesting. So for me, it's more like the substrate mycelium. The substrate mycelium is really growing into the meat. I mean, I often like to compare it with a tree, having a branch, having leaves, and obviously we can see that. But the huge system of a tree is always under the surface. And this is his giant network of root system, and he's doing there his work. So our mold is acting a little bit like the same. And the clue is that easy. It's a win-win situation, and we're having another product which has a different taste and another texture because he's pushing his enzymes into the meat during the substrate mycelium, and even more, it produces a more constant product. Of course, we're not able to do out of a bad quality meat the best product in the world, but we are able to increase the tenderness and the aroma profile to make it more constant at the end. Well, I've tried to paint a bit. It's not my best one, but it shows you a little bit how the mold is looking like. I mean, we see on the surface these spores. I mean, on the top there are the spores, these little points here in the middle. It's hard with this pointer, but on the middle, these points are the spores. They are just their babies, we call it. The spores are just held by this substrate, by this surface mycelium in a good position, so that the spores are always at the right time, at the right place. And then I tried to symbolize this substrate mycelium who is growing into the meat and doing there his work. With the knowledge we got before, it's easy to understand what the proteolysis is. It's just the breaking of the proteins. I mean, collagen is a protein, so what are we doing? We're just going and break these huge building, this really not so flexible binding, break that with those enzymes and doing the just small cuts on different places, and so the whole structure get a little bit more flexible and tender at the end. I did forget to explain what biocatalysts, I mean enzymes, are. So we often talk about that, but it's really just a biocatalyst. That means it helps to doing reactions in the body. And again, it's 100% naturally. I mean, enzymes are all over in our world. I mean, in our body, in our system, and also in animals. So what we are doing, we're just pushing more and more enzymes into the meat and making these breakings of these huge buildings. We saw the set discs before also, so I mean, the set discs get a little bit broken and a little bit more flexible, and also all the stuff which is around the cells, then the degradation of this extracellular matrix is also part of the proteolysis. On the other hand, we have to change the aroma profile, which is also really important for you as a chef in the kitchens. I mean, it's just we're producing more free fatty acids. So, and you can recognize the free fatty acids in your dishes because they're just slightly going faster into the environment, and you can recognize them in a really good way. This modified aroma profile is slightly different. You're getting now the pork neck here. The Luma pork neck is just matured for about 5 weeks with our mold, cutting, trimmed at the end, and then at the end it's served here as a dish. The modified aroma profile from the pork, it's more like a little bit on the nutty side, and also some cool cognac notes, or mainly cognac notes, and some other notes in case of nutty, and some blue cheese notes are also often described. But my topic is ending there, and yours starts. I mean, there you are the chefs and can produce some cool dishes out of a product with a modified aroma profile at the end. Very important topic, food safety. It's not just a mold which we're applying. I mean, it's a natural mold found in our environment. What we are doing, we just isolated the mold and bring it in our master cell bank. That means it's just stored with liquid nitrogen at minus 200 degrees to hold always the DNA stable. And we're just putting always a little bit of this master cell bank to a working cell bank, and from there it's gone then on the meat. So that's the only way to ensure that the mold is always the same, has the same DNA, and of course is doing the same changes in the meat as we're looking for. And also the speed of an enzyme, or the enzyme power, is always during generation, it's going a little bit lower and lower and lower. So that's also a trick to always go back on the mother culture, because the mother culture is mostly the most powerful tool we have here as a biotechnologist to use. And really important is our mold is doing a strong suppression of undesirable floras. That means other bacteria or molds are not having a big chance to grow on that, because we're doing that in really in a high concentration solution. We're bringing our mold on the meat, and he's doing there his work. Of course, it's kind of a fight on the nutrition on the surface, but as we're bringing our mold in billions and billions of spores on the meat, so it's easy to understand that he's pushing away all the undesirable flora. And of course, he's producing no mycotoxins. Really important topic if you're working with products like that. So our mold is not able to produce any toxins. He has that not in his DNA, so we're absolutely safe. On the next picture, we're seeing these maturing phases. I mean, it looks a little bit crazy. On the first meat piece on the left, it's just a good ground product, high marblet, really in the beginning of our maturing process. Then it starts the maturing phase, and after 3-4 weeks, I mean, it looks like at the picture really on the right side, so it's finished then. Between our several stages, I do a shortcut here a little bit, but our mold is covering the surface of the meat really, really fast and in a good way. So that's the reason why we selected this mold, because he's pushing hard all other undesirable flora away, and he's growing at low temperature and really fast. And at the end, it looks like in the piece of meat on the right side. So our butcher is trimming then the meat, debone it in case of a strip loin here, and trim the surface. After that, it gets vacuum packed, shock freezed, and then it's ready to ship. If you're looking in our maturing rooms, looks a little bit crazy. I call it often the meat heaven. So we're producing here a lot of beef, pork and veal as well. And it's not that easy to do it in a room like that. You can't just start your dry aging with a normal room, so you need to check several parameters all day long. Temperature, really important, of course, for maturing meat, but it's also about the light influence. It's about the windbreakers you need, and it's also about, of course, the humidity in the room, because it's not just the mold doesn't like to grow in a too dry area, but also not in a too wet area. So the mold is always a little bit picky. This is the reason also why it needs to be combined with the old traditional method of dry aging meat with a modern biotechnology way. We call it here Luma mold aged. If we are looking a little bit closer, this is an Australian strip loin. This is also 3 weeks matured with our mold, fully covered. You can see how efficient our mold is working here. And if you're zooming a little bit more in, it's get a little bit more crazy. So in this picture, you can see just the mold, which covers here a ribeye, and it's fully covered and doing his work. At the end, we have a cool new product, new possibilities for you in the kitchens. And we're absolutely happy to announce here, Nice to Meet as a partner in the Benelux. And they already have pieces in their warehouses. So if you get hungry now, feel free to contact them, so they will sell the products immediately. Thank you very much for your attention, and I hope you enjoyed this little scientific topic, but it's cool, it's it's trend, and it's future business, and we're happy to be here right away. Thanks.